few mathematicians will be talking about statistics and gambling, and we'll start the lesson off with a quick overview of probability. Probability is a chance an event will occur, the value of probability being 0 and 1. 0 being that the outcome will probably never occur, and 1 being that the event will more than likely or certainly happen. Calculating basic probability is simple. We take all the events in our favor over all the possible ways the event can happen, like the example on the right. The probability of getting a green marble will be 50% because we take 1 over 2. Now let's talk about odds. Odds can be included into probability, but it does have a few differences. As probability describes the chance an event will occur over all the total possible ways the event could turn out, odds measures the favorable events versus non-favorable events. And the value of odds is 0 to infinity. And instead of being expressed as a percent, it's expressed as a ratio. When speaking of odds in gambling, you'll often hear odds against and odds in favor. The example on the right shows odds in favor. And the key difference in calculating odds is not adding the favorable event back into the denominator, but to keep it separate. To calculate odds against, we just reverse the calculation. And on the example on the right, you can see that we have 8 marbles, so we're going to use the marble in the bag. Again, we have 2 red, 2 blue, 2 green, and 2 yellow. The odds of picking a yellow marble will be 1 in 3, as we did not include the yellow marble back into the equation, or the denominator. This displays odds in favor. Now that we covered 2 stats, let me explain why these are important in gambling. When gambling, probability and odds can be used interchangeably, and it can help determine your chances of winning. When given a fractional odd, for example, 3 over 1, we can use the formula b/a plus b to calculate the probability. So we would get 1/3 plus 1 equals 0.25, or that would be 25% chances of winning, or 25% probability. You can use probability and odds separately to determine your chances of winning by using the favorable outcomes over total favorable outcomes, or favorable outcomes versus non-favorable outcomes to determine your winnings.
You've probably seen people playing roulette in movies. Even if you've never tried playing yourself, you spin a roulette wheel, then it spins a ball in the opposite direction, and you place bets on where you think the ball will land. The roulette wheel has 38 pockets that the ball can fall into. The main pockets are numbered from 1 to 36, and each pocket is colored either red or black. There are 2 extra pockets numbered 0 and 00. These pockets are both green. When placing bets, you can place bets on either a number, a color, or whether the number will be odd or even. There's quite a close relationship between probability and statistics. A lot of statistics has its origin in probability theory, so knowing probability will most likely take your statistics skills to the next level, trust me. Probability theory can help you make predictions about your data, see patterns, and make sense of apparent randomness. You'll see what I'm talking about later. This will also help with winning roulette. Probability formula is the number of ways of winning over the number of possible outcomes. Probability is a way of measuring the chance of something happening. You can use it to indicate how likely or unlikely an occurrence is, as stated earlier by Kareena. Probability is also measured from 0 to 1. So on a scale of 0 to 1, will a freak coyote attack me? Impossible. Less than likely. 0. Will I fall asleep at some point during a 168-hour period? Certainly. And if I was to throw a coin, with it landing on heads or tails, what is the likely chance that it will do either? 50%. There's a 50% equal chance of it happening or not happening. So let's take a look at the roulette board. Let's assume we want to bet on number 7. This is example number 1. Looking at the roulette board, there are 38 pockets. Don't forget that the ball can land on 0 or 00, as well as the other 36 numbers mentioned earlier. Out of all the pockets, we're looking to bet on number 7, meaning we're betting on 1 pocket. To work out the probability of getting a number 7, it would be 1 over 38. The answer is 0.026. On a scale of measuring probability, the probability of getting 7 is 0.026, so it would fall around here. It's not impossible, but not very likely. 1 out of 38 chances. This is example number 2. We're betting on black and red. 18 black, 18 red pockets. The total would be 36 over 38. That would give us a 0.947% chance of the odds being in our favor. And our probability percentage would be very high, almost certain. Another option is betting on green. That would give us 2 out of 38. 2 pockets are green out of 38. The probability chance is 0.052. Most likely, out of all 3 examples, the best event for us to bet on, is the red and black. That gives us again a 0.947% chance, and it's almost certain that we would win.
Well, I'm going to talk a bit about probability in poker, more specifically Texas Hold'em. Texas Hold'em is a fairly simple game to understand. Each player gets 2 personal cards, and on the table, the dealer puts 5 cards facing down. There's a first round of betting to decide if you're gonna play or not based on the only cards you can see, which are the ones in your hand. After the first round of betting, the dealer turns the flop, which are the 3 first cards from those 5 on the table. So now you can see 3 cards plus your 2, and you have another round of betting. So you're deciding if between those 5 cards that you have, if you have something that might win this game, based on the rules that you can see on the slide on the right side, which explains the combinations of cards that makes the most amount of points. After the second round of betting, they turn the 4th card's turns. That's called the turn. There's another round of betting, and the last card called the river is turned. And now all the players that are still playing can see there are 2 cards plus 5 that's on the table. The idea is the best combination of those 7 cards, getting at least some kind of combination, 2, 3 cards, maybe even 5 of them, to give you the most amount of points. If you look on the right side, as I said, the poker hand rankings, you can see that just 1 card, if you have an ace is the highest card on poker. If nobody else has anything that makes any points, you would win with the ace. However, an ace or a high card is not the best you can do in poker. So if someone has a pair, it doesn't matter which kind of pair, they would win because it's a higher point that gets you more points. If someone else has a pair, you would compare the numbers between the cards, and so it goes. So you can get 2 pairs, you can get 3 of a kind, a straight, a flush, a full house, 4 of a kind, straight flush, and royal flush. So understanding the combinations of cards and getting the best one possible is how you win at Texas Hold'em. To understand a little bit more about Texas Hold'em, I'm going to explain some of the combinations of cards and their probabilities. Not all of them are going to be explained because some have really complicated probabilities involved that we have not covered during this course. The first thing we got to understand is how many combinations there are when considering 7 cards. So as I said before, a game is composed of 5 cards on the table and 2 for each players, which means each one of them have 7 cards that they're playing with different combinations. Out of the 52 cards on the deck, 7 are going to be used. So when we calculate 52 over 7 times 45, which is the difference, you get 133,704,560 possible combinations. The first example I'm going to give is the royal flush, which is the highest value combination of cards a player can get. It begins with a player finding 5 sets of cards, which involves the A, king, queen, jack, and 10. So they need those 5 cards. They need to be the same suit. However, 2 other cards are going to be on their hands or on the table. Those two other cards are random cards and can be from any suit. It doesn't even impact the royal flush. So taking out those 5 cards, those 2 random cards are found out of 47 remaining cards. So when we combine the 47 with the 2 random ones that we need to find, we get 1,081 possibilities. Considering that we have 4 different suits that we can get, the 5 sets of cards, there's 4 different permutations. So 4 times 1,081 divided by our number of total combinations that we calculated just a minute ago, we get a percentage of 0.00323%, which is a really low probability of actually getting a royal flush. Another possible combination of cards is called the straight flush, which are 5 cards of the same suit in order. However, it does not include the ace, king, queen, jack, and 10, because that would be a royal flush, as we said it before. So there are 9 possibilities for each of the suits for a combination of 5 cards that comes in order after you exclude the royal flush. Since we're excluding the use of ace, we only have 46 remaining cards that can be chosen for the 2 extra cards. So we have 5 in order, 2 extras. Those 2 extras are chosen out of 46 cards that are in the deck. When we calculate the combination of 46 cards possible, just getting 2 random ones, we find that there's 1,035 possibilities. So having 1,035 possibilities times the 4 possible suits that we have, times the 9 possible outcome combination orders for each of the suits, and dividing all of that by the overall number of combinations that we have for 7 cards on a deck, we find a 0.0279% chance of someone getting a straight flush when playing Texas Hold'em. I'm also going to talk about the 4 of a kind, which is basically having 4 cards the same value, and of course different suits, and 3 other cards that are not the same value. Those 3 cards can be chosen out of 48, 52 minus 4, the 4 ones that you already have, and there are 13 possibilities for you to do this, because there are 4 different suits and 52 cards on the deck. When we do a combination of 48 cards, when we have to pick 3 that are random, we find that there are 17,296 possible outcomes. We multiply 17,296 by 13, which are the number of possibilities for you to get the same card, and dividing again by the number of possibilities of having 7 cards altogether on a deck of 52 cards gives us a 0.168% of someone having a 4 of a kind hand. Thank you for listening to us, and that's it for probability in gambling. Have a nice day.